What is flow architecture? How is it going to help in any modern enterprise? This is the discussion we are going to have today in this show. Modern Enterprise Tech Show. This is a weekly live stream we host at Rishi.Research, and we talk about various topics that is of use to enterprise decision makers and enterprise stakeholders. My name is Krish Subramanian. I am the founder and host of the show, and I am with James Urquhart, who is a good friend of mine, and he is one of the early Cloudratty member, and he has been with us talking about cloud and other topics for a long time. In fact, he is the one who coined the term Cloudratty. James, welcome to the show. Can you introduce yourself and talk a little bit about the book you wrote recently and that is going to come out soon?
Yeah, thanks, Krish. And I created a joke label that went a lot farther than we expected with that Cloudratty thing. So that was that's kind of one of those things where I kind of laugh every time it comes up. But it's good to see you again. So I'm currently play a executive advisory role at VMware in the Tanzu team, the what's called the Modern Application Business Unit. And we, my job and my colleagues' jobs are to work with senior leaders at our customers to help with the strategic aspects of modernizing their application development practices. Things like how do you organize your teams, and what are the ways that you can manage headcount as you're working on productizing a number of the things you've run as projects in the past. Things like, what are the financing models that really work well? What are the right ways of beginning to break up monolithic applications into the component pieces? And, is there an order that should be done in the portfolio for various reasons? So a lot of kind of strategic talk like that. But on the side, I've written this book called Flow Architectures, The Future of Event-Driven Integration. And the topic of the book will be in print in early January. You can pre-order it on Amazon, and I think you'll probably share the link with everybody. But the topic of the book is really looking at event-driven architectures from the perspective of how they might be used in integrating across organizational boundaries. So allowing one business to send real-time information to another business or a government agency or whatever it might be in order to collaborate digitally in real time and more effectively. And as I was doing evaluation on this, I quickly came to the conclusion that as this practice happens more, the interfaces and protocols used to do it will become more and more standardized and commoditized. And when that happens, when we have a standard interface and protocol to do this form of integration, it's going to allow for a massive change in the way our businesses work together in the future. It will be a fundamental shift in the way that we do digital business and cooperate and collaborate digitally in the future. So the book goes into depth about what I mean by flow, what the kind of the traits of all that is, what are the business drivers that need to be there, what are the technologies today that give us some idea of the shape that it might take in the future. And then I use some wordly mapping to not only identify sort of what are the key components of flow, but also how might those components evolve in the future, and use some promise theory to validate the wordly map as well as I go. So there's if you're interested in wordly mapping and promise theory, there's a lot in the book to help you, at least with some sort of specific uses of those technologies for predicting future technology. Awesome.
Let's talk in more detail about what flow architecture is, and I am really looking forward to the book, especially following what Simon Wadley has been doing about Wadley mapping and Mark Burgers about the promise theory. I think it's going to be an interesting book. And before we sort of like talk more about what flow architecture is, let's set some context. How are applications being developed and deployed today? And if we can set some stage for how it is going to change as we embrace flow architecture, I think it'll be good.
Yeah, I think, one of the biggest themes that I've seen happening over the course of my career, almost 30-year career in enterprise software, is this movement that we slowly make towards more composable regimes of building the complex systems that we have to operate with. And the economy itself is a complex system. Our business applications are automating that economy in various ways, and so necessarily our business systems become part of a complex system, and themselves can be very complex. So as we move with that complexity, we go away from this idea of sort of some very rigid, strong, highly defined elements that have to be done a certain way, and begin to look at ways that we can take smaller, more flexible components that work extremely well at what they do and bring them together. So we've seen this with, the breakup of large-scale monoliths into service-oriented architectures, which then evolved into basically just smaller monoliths over time. And now this breakdown into more microservices type architectures, where what we're trying to do is begin to understand what are the building blocks, what are the common commodity elements that we have in our environment, what are some shared elements that we should make easy to use, and put those together. And so software development process and the automation we've done around that has also been going through a similar change, right? So it itself as a business system, we've gone from these very firmly defined, standardized, optimized systems, which were incredibly well at building the various things that we wanted to build over time and deploy over time. Well, actually, we started out with with basically hand coding everything, and then we began to build systems that said, hey, for a web application, this is the way that you deploy and run a web application. And it would, essentially you would put your code in, and it would crank out a web application. Even back in the days of Tomcat and J2EE early days, we had systems that would do some of that. And now what we're beginning to see with Kubernetes is the opportunity to begin to step back and look at, since capacity is so readily available to be provisioned where we need it, we're beginning to look at software development a little bit more from a factory viewpoint and a supply chain factory delivery kind of model, which was always the intention, but was always very hard to get to. And as we look at now with our kind of factory eyes at this, I think what we're seeing people figuring out what are the basic manufacturing processes to get software out the door and in front of customers. Specifically, we're beginning to narrow down the ways that we can work on web applications, mobile applications, and now increasingly event-driven or streaming systems. And so as you begin to bring those pieces together and have some commonality there, we have standard building blocks that we can put into opinionated flows, but we're now more able to allow those opinionated flows to be made up of composable pieces where we could alter those flows if we need to, and allow for more variance and more difference in what we build, how we build it, where we deploy it. So I think what that says is if you have a composable system, you need a way to communicate activity across all of those different components to complete the flow. And that's where I think event-driven systems are going to come in to software development and begin to change the nature of the way that our development tool chains interact and communicate. They're going to be a lot more event-driven. They're going to be a lot more sort of reactive to what the previous step has completed as they go. And it gives us a lot more plug-and-play capability to kind of move things around or insert things into processes than we can. What about you? What are your thoughts in terms of how the evolution of software development is happening, given the nature of some of these new tools that are available to us?
Yeah, I think I more or less agree with what you're saying. In fact, I am a big fan of composable enterprise model, which Jonathan Murray put forward when he was CTO of Warner Music Group. So I've been thinking about it for a long time, and I thought maybe containers are the ones that's going to take us to that model. And with microservices and containers, I thought that is going to help us move towards a more composable enterprise. But as you mentioned, Kubernetes is helping us there, and with the development of functions as a servers and event-driven platforms, I think now we are seeing a real possibility of achieving the dream of sort of like making your organization itself much more like a Lego pieces put together, and then build out the necessary infrastructure, applications and other related services, so that the organizations can fit into the applications can fit into the organizational needs in a much more coherent way. I think I'm still like digesting how these different technologies are evolving, and I sort of plan to sort of like put together my thoughts in the coming months. And I think your book is going to help me understand it much better, and probably have some clarity in what it means to build a composable enterprise. So if you are watching the show and you have any question to James, feel free to post it as a comment in YouTube or Facebook or Periscope, and we will get James to answer the question. James, let's now talk about flow architectures. Can we define what it is, and sort of like talk about how it is going to benefit a modern enterprise that's trying to sort of meet today's needs, especially with the current pandemic and with all the issues we are facing today? The need to transform organizations has become more critical. So can you talk about flow architecture and how this is going to help organizations transform themselves?
Yeah, so the basic definition of what flow is about is it's about integration across organizational boundaries using event-driven architecture. So then the next piece of the puzzle becomes, so what are the traits of that? What does that look like in terms of why it's differentiated from, say, doing APIs? And that's the other question I always get is, how is this any different from APIs? And really the difference comes from a request response model versus a push model. And so really inherently flow is a publish and subscribe model. It could be looked at some other ways, and I explored that a little bit, but what I really focus and what it all seems to boil back to is it's really about producers of information being able to in some way publish that information so that it can be consumed by consumers, and consumers having a mechanism to subscribe to flows of information that are of interest to them. Now, the mechanisms behind that have to do certain things. So first, the producer has to ultimately own who gets to see what data. Now, they may delegate that function to an agent, an underlying service that handles the publish and subscribe relationship for them. So the producer may just say, hey, I'm just going to put events into this third-party service or this underlying infrastructure component that takes care of this for me. But they ultimately own the right to say, this is the policy I want applied to my data, this is when I want this to be made available, and this is the form in which it's being delivered. And consumers need the ability to determine when they want to connect to a topic that they're authorized to connect to and when they want to disconnect. So they ought to be able to do that entirely independent without having a dependency on the producer in order to be able to make that decision. So the producer doesn't even necessarily need to know who the consumers are of those systems. And so for me, that's kind of the core thing about flow is creating this sort of this common interface. So this common connection interface, an API or some other interface that enables you to connect to the topics that you either want to publish to or subscribe from, and having a common protocol to describe the metadata for the event, give some context around what the event payload is about, and then ultimately in the long term, there'll be some common standards, probably by industry or even by by sort of ecosystem around what those data payloads look like as well. But the important things are really the metadata has to be fairly standard so that any system that has the right libraries that know how to read that and handle that metadata can process any event that comes in, whether or not it can read the payload. And also at the same time, that the interfaces are standard so that we could build libraries and tools that allow us to just simply say, hey, I want to connect to that topic. And with some URI of some sort, say that's the topic I want to connect to and have that connection be made. And hopefully even optimized in terms of latency, in terms of what locations you connect to get to that stream and so on. So that's kind of the basic of the technical basics of what flow is. From a business perspective, what flow is really the ability for you to be much more granular in the ways that you provide or consume real-time information about activity that's going on with others. And lowering the cost of doing that significantly by orders of magnitude so that you can experiment with and even apply use cases that were prohibitively expensive or that are prohibitively expensive today and have been in the past. So it's really, it's a democratization of real-time data streams through standard interfaces and protocols in that way.
So, Lawrence is asking, workflow is nothing new. Aren't you taking the work of the word with regards to flow architecture? I think, Lawrence, I think James made it clear what he means by flow architecture, and I think that should answer that particular question.
I can just a little bit more on that, right? So workflows can be built from these kinds of integration, but not all workflows require integration across organizational boundaries in any way. And so not all event-driven systems will be flow systems. Not all workflow systems will be flow systems. But certainly workflow systems and building workflows from composable pieces is definitely a part of what the goal is here. So absolutely, I'm not co-opting the term workflow because that has a very specific definition in terms of the movement of work through a system. I'm then saying here's a technical concept, and that's using events, state change information to drive workflows and allow you to build workflows in a number of different ways.
Let's sort of like make it a little more clear to people about these architectures. What are the tools that are already in the market that sort of will help organization embrace flow architectures? Can you sort of walk us through that toolkit that is already there or that's going to come in the near future and help us understand how modern enterprises can use these tools to embrace flow architectures in their organization?
Yeah, well, I think the core of it is really event-driven architectures with an eye towards how you might share some of those flows outside of organizations. So, I go in the book into some detail about the current state of the event-driven market and in terms of the technologies that are involved. When I do my Worley mapping, I identify essentially 14 components that I think make up the core of what flow is. They're divided into two general categories. So one is the actual integration connection, which I call, which is composed of the interface and the protocol. And, there's two kinds of interfaces. There's discovery that has to be there, and then there's actually establishing the logical connection. And there's two kinds of protocols. There's the metadata protocol and the payload protocols that have to be there. And then but flow that integration is of no use if there's no interaction with the flow. And so a gentleman by the name of Mark Anderson introduced me to this concept of, flow without interaction is kind of useless. It's just movement. So interaction is the difference maker. And so the interaction components, I really boiled them way back to core concepts of having processing of some sort, having queues, in order to be able to store and retrieve information as it's needed, having sources and sinks, kind of core to event flows. And so with those kind of basic patterns, plus the infrastructure underneath to support that, which includes everything from cloud infrastructure to TCP, IP, and TSL, and a number of other things that are out there today to help support all this. we kind of have building blocks that can support a commoditized interface and protocol when they appear in the market. And I would say anything that you've got out there today that does event-driven well. So if you're using Kafka today, that's great. I also suggest that, and have some ways of considering other technologies you may want to use. Swim.ai is one that I mention fairly often. There are times when having a stateful digital twin model of your environment is a much better use of event-driven technology than Kafka would be. There are times when using basic messaging systems is a better decision than even using Kafka. But good event-driven architectures where you then consider what are the interface points where we'd want to expose these streams outwards to others, or where we'd want to consume a stream from one of our partners, or from, say, a government weather feed, or whatever it may be, right? Identifying those points and beginning to build those so that they can be really adaptable to the changes that come in the future. So not tightly coupled to any one way of doing things, but capable of making some adaptations easily. I will say one technology that I would look at very closely if I'm considering how can I begin to standardize around something that may become a core of Flow in the future, is the CNCF Cloud Events project, which I'm seeing popping up in more and more places every day. So even since I wrote some of the chapters in the book, there have been a couple of other things I've run across. For instance, we were talking about dev tool chains. So Tekton, which is a really great CI component to kind of bring into your environments, it will emit cloud events for the activities that it does. That can be consumed downstream by something else that knows how to consume. And so I would anticipate things like Argo or which is CD, or other tools that are available in the Kubernetes ecosystem to begin to emit and consume cloud event as well, and to allow you to assemble tool chains using technologies that ultimately where the payloads, the metadata is described by cloud event standards. And so that's one area that stands out to me as beginning to be take shape. Although will it be the long time winner? I can't predict that, and so you have to be ready to adapt as the industry adapts.
Yeah. Before we talk further about the Flow architecture, a slight detour here. Do you expect CNCF cloud events to be embraced by all the hyperscale cloud providers in their functions as a service offering?
So I follow that mailing list for that team, which is basically it's a working group within the serverless working group of CNCF, and I follow that fairly closely. All three of the major cloud providers have been active on that list, and I believe very strongly that you're going to see anywhere where events cross the organizational boundaries of those cloud providers, that cloud events will be supported. But I would not be shocked if in the course of the next 3 or 4 years you don't see all three of them adopt cloud events as the standard payload or standard wrapper for their events internally as well. Even though AWS has a great event ecosystem already in place, there's some good reasons for them to consider, hey, maybe adopting a standard for even passing events internally over the long term. So anyway, it's hard to be firmly predicting it, but they are all involved. Pretty much all of the major vendors that are involved in infrastructure have somebody that's involved, and have had active involvement in the development of the standard. It really does have the support of the pieces that need to be there to make it work. And it's starting to have consumers of the standard that are actually delivering tools that use the standard, starting to appear more and more often, as I say. So there's a growing set of folks that are implementing Cloud Event as their event format to pass to others.
With edge computing and IoT coming into picture and data getting processed at the edge, do you expect to see some sort of standards emerge for flow architectures so that it gets much easier? For example, I'm seeing companies popping up trying to take serverless to edge and IoT and all those places. Ajax is one good example of that. So do you expect some sort of standardization is critical for making this kind of flow architecture work across cloud, edge, IoT, and whatever kind of distributed architecture we end up with?
It's a question of cost to value. I do, because I think that if everybody is beginning to use the same basic mechanisms to transmit and receive events over the network, then you are able to then build libraries and other supporting tools to support those standards in ways that then mean that developers don't have to do that work anymore. So if a developer wants to connect to something, they simply say, okay, here's the URI I want to connect to, and the underlying system takes care of establishing the network connection, establishing the subscription, establishing any other security exchange of information that has to happen, and then the events can be transmitted. And when you receive the event, you can read enough of the metadata payload to understand, can I process this event? Is this what I expected? Where does it fall? Where should I route this event within my system to do processing or to queue it or whatever it is? And all of that, again, can be mostly code that you just say, here's my rules, and the underlying system takes care of it. That lowers the cost of doing this integration so much that I think it behooves everybody that's in the space to say, yes, let's find a common way that we can exchange these events, and let's find a common way, therefore, that we can essentially make sure that our products will work within pretty much anybody else's ecosystem within reason. Payloads are always the catch, because payloads are going to differ wildly depending on the use case. Hopefully, I believe industries like the insurance industry, the financial services industry, healthcare will define common payloads for common use cases, and that will mean that you can connect and you'll know how to read all of that. But that will take time, and all of this to me is a 5 to 10 year horizon thing before it even really hits that the most mainstream companies are considering it in a serious way. And part of the reason is that. Part of the reason is we don't even have the standards defined or even beginning to be adopted by the general market yet. But part of this is also that really there's a lot of infrastructure that has to begin to form by those that need it the most in order to entice others to try things that they wouldn't have tried otherwise. And it's when you cross that line and people are trying things they wouldn't have tried otherwise, because now it's cheap enough to give it a shot, that you'll begin to see that Cambrian explosion of use that creates the network effects that makes it, critical and game changing. So, a lot packed in there, but I do really believe that that everybody that's involved in edge computing, that's involved in serverless, that's involved in the long term, it behooves them to find a common way to package and send event payloads between any system that wants to consume it, because it will open the door. There's no differentiated value in how you transmit an event. So it'll open the door to enabling you to be part of ecosystems or to generate ecosystems around the tools that you do in new ways.
One of the main reasons we are having this discussion here with James is to get people talking about flow architectures. James wants to initiate this conversation so that we can sort of like work together as a community and help others embrace these architectures. If you are watching the show live, or if you are watching the show as a recording, add in the comments how you're using these event-driven architectures in your organization. Or you can contact us on Twitter, like I am at Krishnan on Twitter, and he is at James Urquhart on Twitter. You can start the conversation with us in any of these social media sites. So James, let's shift gears now and let's talk about what are some of the limitations of these architecture and how organizations can overcome these limitations, and how it is going to impact the organization and how can they overcome these limitations.
Yeah, I think in terms of limitations, it's hard to identify what long-term limitations is. Obviously, in the short term, If you're going to do event-driven integration today, there's a lot of fairly low-level work you have to do in order to make sure that your payload not only reaches its destination, but is also interpretable, or that a payload that you receive is not only that you recognize that you received it as, in a timely fashion, but that you also are able to interpret what happened. So there's a lot of coding that has to happen right now. And I think that that's why you see event-driven architectures being incredibly valuable where they change the game. So things like real-time inventory, things like, I mean, it's been forever in the stock market. It's been forever in a number of other areas, but you're seeing, I'm hearing a lot about trucking and logistics being really changing kind of the methods by which they allocate payloads onto available capacity. So I start the book with this sort of fake article that's written there, hypothetically 10 years in the future, and talks about all the changes that have come. And I really kind of focus on a few different things that are really critical. One is that we can reverse some of the relationships we've had around some of the data sets that have been there, but we're going to have to agree to make those changes. Like in education, every institution owns that you've worked with, they own your transcript. You have to go to them and sometimes pay them to get your transcript. We've really got to agree that, all of that information should actually be stored with something that represents the student as an agent, and then all their skills can be collected, not only just their grades from an institution. And so I think that some of the limitations here are that in order to really be effective, there's a chicken and egg problem between the way we practice things today and the way that event-driven architectures would work best to solve a similar problem in the same space. Financial services will be an interesting one to watch. There's a lot of batch processing. In fact, I've talked to a number of people in financial services, and they all agree that pretty much every digital financial transaction that happens that's not Bitcoin or something like that, pretty much every dollar or state currency transaction that happens goes through batch processing at some point before it's fully reconciled. So, there's a ton of practices we do today that are open to being revolutionized by this, but at the same time, there's a cost to that. There's a change to practices and culture that's affected by that. And I think that's the big thing. I think the only thing that will overcome it is people have to discover the benefits and advantages of event-driven architectures for their situation by experimentation, by identifying situations where this is how we should build this application. And then over time, the integration problems are going to appear. And over time, those integration problems are going to then drive the need for the flow architecture stuff that we're talking about. And so, again, it's an evolution. Pieces and parts are coming together today. I think it's important to get ready for this future and to be building applications with this in mind so that you're not caught flat-footed when it kicks in a big way, that you can take advantage of it. But I also will recognize that for companies, it's not, I wouldn't put it as priority number one that we get flow ready this year, because I think it's probably a little premature for that.
Yeah. So one of the challenges I see for flow architectures is the trust factor. The trust factor can be brought in by sort of like offering guarantees, and it's not just for the flow architecture. It is the case with any composable architecture model. Take microservices. Trust is critical, and guarantees are needed for it to work properly. How does promise theory come into play and sort of solve this trust problem, and how can it help flow architecture?
Yeah, talking with Mark Burgess for a number of years about this, I mean, really the core of what promise theory is it's an algebra for cooperation, right, or collaboration. And so if you look at it from that perspective, the way that I use promise theory in the book is I build my Worley map by, the standard way that you do. You identify a user need, you build a value chain of the elements that you need that ultimately deliver that user need. But what I use promise theory for is to validate that my value chain is correctly connected and identified to each other. So making sure that I'm not creating a relationship between two components where there's an implied promise that can't be kept by the promiser because it's making a promise on behalf of another component in doing that, right? Something like that. So in running this exercise about using promise theory to say, hey, does a processor make a direct promise to a producer, right? Or does that processor make a promise more to the flow connection, which makes a promise to the producer? Does a producer make a direct promise to a consumer? Not really, because it can't make a promise on behalf of the underlying infrastructure. So when you begin to think about it that way, who actually makes a promise and what promise is it between the different elements of the value chain? That's how I ended up kind of both boiling things back to this core set of 14 elements, but also at the same time feeling very, very strongly that I have a good definition of a very abstract view of what flow architectures consist of, that I can then begin to plug actual tools and products and use cases into. But I also use promise theory on a regular basis to identify when there are conflicts in collaboration, say between development teams or between development teams and product teams, to begin to identify where are the promises that are being broken or that are not being made that should be made, that begin to hurt that problem. And I think you can do the same thing with systems in the long term as well. Is look at the promises between the different components in your environment, identify, make darn sure that anybody that's making a promise on behalf to another component is doing it on their own behalf, what they can execute, and not on behalf of something else, which creates a dependency that may be unintentional when you do that. So hopefully that answers that question. But
yeah. So we are already over time. Do you have some more time, a few more minutes for us to wind up this conversation? Or
yeah, absolutely.
Okay. So with that extra time you offered us, like one topic I want to touch upon before we talk more about the book is, what are the use cases you foresee in the future? Like you touched upon some of the use cases you're seeing already in financial industry and few other things. What are some other use cases you foresee in the future where flow architectures can be embraced?
Yeah, there's many of them. I identify 4 patterns in the book that sort of give some idea of the different forms of flow integration that can happen, and it consists of a collector, which is a service that collects from many different data streams and then produces something of value out of that. A distributor, which is the opposite. It's like a broadcaster. It takes some input of events and then broadcasts that to many. Maybe it does some processing or routing, or maybe just broadcasts everything out. And then there's a single processor pattern, which is basically something that takes a lot of inputs and a lot of outputs, and basically coordinates. It can be a two-way conversations, or it can be lots of inputs, lots of outputs, and in some way either pulls signal out of noise and makes it more intelligent to the consumers that are consuming the output, or perhaps some of those outputs are to sinks, and there's some routing to different sources for that purpose. And then the last one is what I call a facilitator. I could have called it a broker, but that's such a heavy overused term. A facilitator is basically something that matches buyers to sellers. It's a specific specialized version of a signal processor in a sense. But what's unique about it is it's got to find the sellers, and it's got to find the buyers, and it's got to match them. There's a lot of architectures out there today that do this. You've got Uber, for instance. You've got the stock markets, of course. You've got there's many folks that do this, but the question becomes, do the protocols and the interfaces have to be specialized for facilitator use cases, for buyer-seller use cases? Or is it really about, there's an opportunity out there for tool builders to say, hey, we've got a generalized system that can match incoming events with other incoming events to do whatever you want to do when you find a match between those two. And so I think that there's so when I do that, some of the use cases that come out of that become like, you can imagine there's an example of a collector. I create this fictional company called Rental that basically you could rent anything you want that's not a real estate, right? You can go on that site, you can rent cars, you can rent. And the interesting thing about Rentall is they do this as a service and they don't own a single asset that they rent. They are connected completely to rental companies all over the country of different sorts, and they are basically brokering and facilitating rentals with everybody, and become a unique single source of renting for whatever needs to be out there. But there are others that fulfill that rental need when that's done. So it's a B&B for rentals, right? You can imagine, a weather stream if you're looking for more of a broadcast situation. Like the U.S. government would have like something that updates with events. Surprisingly, most of the event things that are available, weather, that stuff that's out there today, are not event streams. They're APIs that you call and make requests to. So you can imagine you event stream, and you event stream updates, say, every minute for the specific set of criteria that is provided by the consumer. It says, I want this specific set of events. And then you have millions, hundreds of thousands, if not millions, of sensors all over the globe that you are collecting information from, and you're doing some processing, and then you're basically broadcasting out to each of the folks out there that needs to happen. And you can look at that as the signal processor as well. And then a good example of something that's a little bit more of a facilitator is something in trying to remember what I used, but something in, say, human resources and hiring, that where I may have information about what my skill set is, and I may be able to send an event that sends a signal that says I'm interested in people and recruiters contacting me. And then with that bit flipped, then all of the activity and work that I do gets added to my history as recruiters are looking for folks that are doing these things on a day-to-day basis today. So if I'm using a certain tool, or if I'm posting on GitHub to a certain project, or whatever it may be, those signals might come into my profile of who I am and what my skills are and what I bring to the table. So there's some interesting things there that I think are kind of useful changes to the way things happen. And what I'm interested in is, when it gets super cheap to do this, what are the things that I couldn't fathom that somebody will go, hey, I can just give this a try because it doesn't cost me anything.
Yeah.
We've all seen it in the cloud world with infrastructure getting so cheap. And I think you'll see the same thing as these streams become cheap.
Awesome. I think you gave us a pretty good introduction to what flow architecture is and how it fits any organization wanting to sort of transform themselves to compete in today's world. So as an enterprise decision maker or an enterprise stakeholder, why should I read that book? Like, can you walk me through what is there in the book and how it is going to benefit me?
Yeah. So, I mean, the core discussion that I make about why the book was written in the first place is, it's because we as technologists tend to be really bad at sitting down and really thinking about where things are moving in the future, and understanding we look at everything as a light switch. Like, okay, it wasn't Kubernetes, it was VMs, now it's containers in Kubernetes, right? Like that happened overnight, but it doesn't happen overnight. And so if you do the right analysis, if you use things like Worley mapping and promise theory and other things, you can begin to get a sense of where things are very likely to move. And I actually make the case that these standardized interfaces and protocols are inevitable from the way that I do the analysis. And so my thought on writing the book is to say, look, this is something you should know about and think about. And you may not agree with me totally. That's fine. Getting the conversation started and thinking about the fact that this trend is out there, or that something like this may happen, is going to benefit you from the perspective of sitting down and thinking about what should we architect now that we may need to take advantage of 3, 4, 5 years out in the future, or what can we at least look at if it's beneficial to us to see something like this happen. How can we accelerate it? What projects can we be involved in? Or maybe it's an industry trade group, and help them define a common payload standard before it's necessary to have a standard specifically for a flow interface. Because if you have that standard payload architecture already, it is much, much easier to say, hey, everybody, we're transmitting, standard X via cloud events now. So everybody, this is how you can consume this data more easily. So it's really, I put it out there. It's a speculative book. I completely admit that freely. In places, it's very speculative. But at the same time, I think I make a really solid case that you should be thinking about this now. And you should be thinking, especially if you're a long-term planner for your organization, you should be thinking about sort of what is the time frame in which we need to get our architects and our engineers really actively thinking about how to be ready for this future.
I agree. I think it's a very good idea that you have started this conversation, and we should talk about flow architectures, and we can discuss whether it's going to fit into the organizational needs or not. These are topics we should discuss in the coming months. And if you think, based on what James said, if you think it is going to work for your organization, add it as comment or tweet to us on Twitter. Or if you think it's not going to work, probably you should tell why it is not going to work. And probably it's a conversation James would like to have. I would like to be the fly on the wall listening to the conversation. It was, I think, fantastic that James has written this book. In fact, last December, I had James in one of the podcasts, and he said he's going to write the book. And now the book is almost coming out. I will add the Amazon link in the YouTube show notes, and I will also give the link on Twitter, and you will be able to pre-order it. James, when is the book coming out?
So the latest I got from the publisher is that it will be printed in early January. So I'm hoping very early January. It's in final QA stages now. I think it's got one more round of QA. I'm doing some QA now, and it's got one more round after that. But it's very, very close. If people pre-order it now, they should have it by mid-January. And I'm very excited to get get it into people's hands, get people reading it, and get feedback. Because I think I write to learn. I always tell people that I write in order to learn, and that's really one of the things that I hope comes out of this as well.
I totally agree. In fact, if you really liked what James was talking in this episode, hit that like button. And if you want to get notified whenever we post a video like this, in fact, we live stream every Wednesday at 1 p.m. Pacific. And if you are interested, you can come in directly for the live stream, or you could subscribe to our channel and hit that notification button, and you will get notified whenever there is a new video in this show. And James, it was great having you today. It was a great conversation. I am really excited about the book, and I think as soon as it comes out, I will read it, and we will have maybe a more detailed conversation in sometime next year. I think this is going to spur some conversation in the industry, and maybe who knows, it might change how enterprises are doing business in the next decade.
Absolutely, I hope so too. And at the very least, I hope it gets the right conversations going, so that we are seriously considering the right ways to use these event-driven architectures in the future. But it's a pleasure always talking to you, Krish, and I always look forward to the next time. So this will be great.